What is going on, everybody? Welcome to something I have been waiting for, and that is the Jetson Thor dev kit. Now, if you're like me, when you heard about this thing, when it was announced, you heard one spec and one spec only, and that was the 128 gigabytes of video memory on this thing. And then you kind of stuck around, you heard the price was going to be approximately about $3,000, and immediately your mind started going on how amazing life was going to be with 128 gigabytes of video memory for $3,000. Oh my gosh. And you could just keep buying these and stacking them up. You might even network them together, and you're just going to have a supercomputer at home. And you tuned out all the other specs, and one of the other very, very important specs is the bandwidth of that memory. So the memory bandwidth on this device is 273 gigabytes per second. Now, in the realm of GPU memory bandwidth, like a 5090 has something like 1790 something gigabytes per second. So 273 gigabytes per second is, in the realm of GPU memory, pretty slow. Now, in the realm of CPU and RAM memory bandwidth, that's pretty fast. 273 gigabytes per second is very fast. You can get there on like server grade CPU and RAM, and I think you're probably going to need a dual CPU setup. So that begs the question, like where does this fit in the realm of something more like just buying a bunch of consumer GPUs or building like a CPU and RAM type setup? Like, where does this fit? And who is this for, right? And this is for this guy, no question. That's where this goes, because the power is, so you power this, at least the dev kit, you're powering it over the USB-C, and the power draw is 130 watts at the max power mode. So 130 watts is like nothing. Okay, that's crazy. And so and the reality is, it's actually just like a little tiny board that's like right here, because all this is, it's like, first of all, it's like hollow here to suck up the air, but this is just heat sink and fan, so it's just like heat dissipation over here. The real board is just right here. It's just this little tiny square, right? And I think that's the T5000 board. So that is what you would embed into your robot, and then you would have whatever cooling situation you need on that robot. But it's going to suck 130 watts of power, which is, again, it's like nothing. You could use this to do local LLMs, and we will do some, and actually this kind of got me into, it's like my gateway drug back into doing local LLMs. And honestly, even to this day, I still use the Puget Systems machine that has a 1 terabyte of RAM, but the memory bandwidth, well, I need to measure that memory bandwidth so I don't speak out of too much turn, but I would guess it's somewhere like 150 to 180 gigabytes per second, so it's also very slow, but you have a whole terabyte of RAM. And when you have a whole terabyte, or you just have a whole bunch of video memory, a lot of times you can do things that you wouldn't normally be able to do. And so I will show at least a few examples of that on this device at least, and then probably have a follow-up video on just local LLMs, period, because those, like, especially some of those like new Quen models are really good, and you can just run them locally. So anyways, but back to this device, I'm trying to think of any other real specs. That I'll post a link. There will be a link in the description where you could pick one of these up, but then also you could kind of review the specs. I don't want to go over every little detail, but basically, yeah, you got the power. You do have a 5 gigabit Ethernet here, and then here you have a 4x25 gigabit port, and you might be thinking like, oh, you can just expand all these out. But again, you're going to come up to this like bottleneck of bandwidth that, like, so 100 gigabit per second is like translates to, I want to say like 12.9, something like that. But the reality, you're probably going to see like more like 12 or something gigabytes per second. So that's really slow. Like if you thought 273 gigabytes per second is slow, yeah, 12 is going to be really slow. So you could scale these out, and you could do some pretty cool stuff. You're definitely not going to train models on this. This is definitely for inference. It's most useful with robots for sure. But you could run local language models on here. And again, if you need to buy all the components, it's still going to be way cheaper than CPU and RAM. Like for $3,500, getting 128 gigabytes of memory that has a memory bandwidth of 273 gigabytes per second. That's a really good deal. I don't think, you can feel free to comment below if you think you could build a computer with those speeds, all putting together all the components. I don't think so. Like, this is crazy. And it's 130 watts of power. Like, it is truly insane. But if you thought you were going to get like H100 speeds with a little more memory than an H100 for $3,000 or $3,500, you won't be happy. But this is still like quite the niche device, and it's so clear that it's for this guy, especially because like on him right now, I've got the Orin NX board, and that has 16 gigabytes of memory. So jumping from that to this new board with 128, huge difference on what you can do, how many models you can run at the same time on that device. But then also I'll show you a local model, like a language model on the Jetson Thor here in a second. And then I'm going to show you something pretty cool, because if you have a ton of memory, you can do some new and novel things to get things to go a lot faster. So with that, I'll stop yapping. Let's get into some demos on this machine now that it's clear what the memory bandwidth is. Here we have the BTOP on the Jetsons showing CPU and RAM, but the RAM is that 128 gigabytes of also video memory. Logging in on another terminal, I show the NVIDIA SMI, but it really just doesn't fully work right now since everything I suppose is so new in beta. I'd have to double check on the older Jetson boards that have similar kind of memory setups, but I'm pretty sure it works. But anyway, the GPU util does work here, and I'll show that later. But BTOP is really the main thing that we're concerned about with the memory, since at least from my findings, the core speed matches the memory. It is paired quite well, but I will show it. Next, I'm going to start up the PyTorch Docker container and then host the Qwen 3 Coder 30B A3B model off the Jetson Thor with Fast API. That's a mouthful. This model is 30 billion parameters, but it is an MOE, or mixture of experts style model, with 128 of those experts, but only 8 are activated at any given time. So we need lots of memory like at the ready, but we won't actually be using all of that memory live. So this side sort of like MOE structure, lots of experts, but only a few activated at any given time. That seems like a solid model for a machine like this, with the sort of ratio of memory to memory bandwidth, like a high ratio of memory to memory bandwidth. Once that's loaded and ready, we can query the server running on the Jetson Thor from our local machine, and we can see here that the speed, I mean, it's pretty decent. It's at least faster than reading and what you'd need for text-to-speech, which for many cases that is kind of the threshold that you need. But it's probably slower than you would want for a local coding like agent model, since you'd want many lines of code, many lines of like thoughts and planning and all that, and you'd want it just so much faster than this. But you are reading every single line of code that the models are generating anyways, right? Moving on, this model is actually pretty impressive to me for its size, both for like coding as well as knowledge of other niche things just entirely. I was asking it about the high pressure oil pump system on a decades-old diesel truck motor, and it knew all about it, which that was like so cool to me. It's never not going to be cool to me just how well these models can compress down just huge swaths of data. I tend to think of LLMs and many neural network models as essentially just like highly lossy compression, but the sheer bulk of data that they can compress and then later retrieve is, I mean, it's just staggering sometimes, especially for these little tiny models like a 30B, which, I mean, I know it's not super small, but in today's terms, 30B is quite tiny. This is the smaller brother of the 480B model, which this 30B also convinced me to download and run. I cannot run that on the Jetson Thor, no matter what quantization, I don't think. I think the smallest quantized variant is like 160 something memory. But I was able to download that and then run that quantized on the Puget 1 terabyte machine, so maybe more on that later. I am very impressed by both of these models, honestly. The 30B is really cool, and that 480B I'm finding to be very nice. But anyways, back to this. This model does quite a bit of yapping here. It's just like me. But we can see the reported tokens per second at the end here from the server as being 6.8. So again, that's on the slow end for sure. Like I would like to see more like 20 plus generally for like even like a local model. I mean, obviously I'd like to see 100 plus, but in general for like a local coding agent model, I like 20 plus. Beyond this though, I did stumble into Open Web UI, which allows you to query your local models easily and have a nice pretty UI, which I also thought was cool. So even though I probably wouldn't use this model for like actually coding locally necessarily. It depends on its performance though. Like if you don't have to keep re-asking it to fix things, like if you have to ask the 20 tokens per second model to fix something 3 times in a row, well, suddenly that 6.8 that just does it right the first time makes a whole lot of sense. So here I'm asking the Qwen 330B model its thoughts on these specs, and I find it somewhat amusing that Qwen 3 is confused by these specs. Not sure if they exist, which, you know, it's probably sort of correct on at the time of training, and if they do exist, it's probably for some futuristic concept or like niche card. Also generally interesting that it finds 273 gigabytes per second to be high bandwidth. I take issue with that. It is definitely not. Besides LLMs, the biggest thing I really wanted to try out was VLMs, and then of course VLAs. I haven't really hooked the Thor up to any particular robot, so I can't really do a VLA just yet. But the VLM that I just particularly love, apparently I have not liked. Oh my goodness. Anyways, is this Moondream 2. The amount of yapping I do on this, you'd probably think they were sponsoring me or something. They're not, and as far as I know, it's just this one dude that does this model, and this is, I believe, the best VLM given its like size and like performance and accuracy. So if you're not familiar with like VLMs and VLA, so a VLA is a vision language action model, which takes like visual language, and you could put in like sensor data and all that, but basically it translates to literal like robotic actions. Like it's almost like a function calling for your motor based on vision and language input or something. And then VLMs are just vision language models that you can interact with image data with language. So scrolling down here, basically what can this model do? In particular, you can do just short caption. So like a caption of any image, just tell me what it is. Like, so short is just a little quicker. So if you want it to run faster, the short caption will be faster. You can do a longer caption. This does like sometimes like many sentences. You can do a visual query. So you can ask a question like how many people are in this image, but you could ask like anything. So I'll try to expand on that in a minute. But you can also do object detection for like bounding boxes, and then points, which just literally gives you like a precise coordinate location of, because a lot of times you'll do object detection and then you got to do the math, like what's the center of the object so you can get a point. But in this case, you can actually just do straight up a point. Also, interestingly, I have personally found there's a difference in performance, like accuracy, between object detection and pointing in this model. Not really sure why. Maybe there's different training data for these two tasks. I don't know. But I find pointing to actually be a little more reliable even than object detection. But anyways, the thing that I think really blew me away the first time I found this, and still is just crazy to me, is this is object detection and visual querying and stuff like that of anything. So it's not like this model was trained, okay, help me find like people, dogs, cats, birds, chairs. Like if you're familiar with object detection of the old days, right? You had like a list of 30 objects that you could track. You could fine tune for new objects if you wanted, but you were very limited. But this is visual information and object detection of literally anything you can describe. So if you want to, like in the G1 series, I showed like you could track the orange water bottle or the red water bottle, or you could identify the microwave, as you could search for microwave, or you could search for thing to heat up food, right? That could be the search, and it finds the microwave. Like, so it's just so cool. And then also you can do something like visual querying, like what are the objects in this video, and then you could label it, or you could say, you know, what are the things that are on the floor right now that should be picked up, like name those objects, and then later you could pass through a pointer, like find those objects and like literally point them out, right? You can do just so many cool things with these VLMs. So like I'm a huge fan. So anyways, let's throw this up on the Jetson Thor and show its performance. And here's the result of Moondream 2 running as a server on the Jetson Thor devkit to detect a red bottle of water. We're getting about 2 frames per second of detection here, and yeah, that's pretty slow. Enter pipeline parallelism. So what we have here is a nice little UI that I had an LLM make for me, a lovely era that we live in. I was going to draw this out, and then I was like, wait a second, I can use LLM for this. So this is just depicting a simplified example of the problem that we have here, and that is, so if we run this one Moondream server, it takes about 5 gigabytes of memory to run the Moondream 2 VLM model. So you run that server, let's say there's just for ease of simplicity here, there's a 500 millisecond latency. It takes 500 milliseconds for this model to receive the input, generate the data, send it back, and us get the result. Our current bottleneck, we know our bottleneck is the memory bandwidth. It's not our networking speed. It's not our core speed. It's not our memory. It's none of these things. We know the bottleneck, and it's that memory bandwidth. But here's the thing. All of the memory has that bandwidth. But we have a ton of memory. So when you have just one server, and it has this 500 millisecond due to the memory bandwidth, right? You are sending, you're able to basically receive an update to the image, essentially this fast. And so like when you're watching, this is our little FPS ball, I'll call it. It doesn't look good. It's jittery. It doesn't move smoothly. But we have all this other memory here. So we can immediately make things better by if we just jump up to having 2 servers. So we're running 2 totally separate Moondream 2 VLM models. And then every other frame we're sending essentially every other frame to each other model. So frame number 1, 3, 5, and so on goes to Moondream server number 1, and then frame 2, 4, 6, 8 goes to Moondream server number 2. And with that, we can achieve double the FPS, and the latency actually stays the same, because the latency is just, again, it's the memory bandwidth, essentially, is our bottleneck. So the latency doesn't change by adding more servers. So of course, we can add even more servers. So we can jump up to 10 servers, right? And now you can see our ball is updating a little smoother. We still just have that 500 millisecond of latency, but now we're up to 20 FPS. And then of course, you can see where this is going. We're gonna go to 15 servers, get a FPS of 30. The ball moves nice and smooth. We are not exceeding our Jetson Thor memory. So then of course, the next follow-up question is gonna be, okay, yeah, well, what about the GPU utilization? So that does show up on NVIDIA SMI. So let's run an example. The first thing I'll show is just a query of, point out the object, the thing on the floor that should be picked up, which I think is pretty funny. This is a perfect example of why VLMs are just cool and why I really like this one at least. So as you can see, it is pinging that. If you saw in the other one, it's like a glove or something like that on the floor. I just think it's so cool that it identifies that. But anyways, you can see the GPU utilization here as getting as high as I think I saw a 97 there. For some reason now it's saying 0, but there it goes, 97 again. We probably could change it to be faster than every 2 seconds to get a much better read here, but you get the idea. We are running a high GPU utilization here. So if we wanted to then run another LLM or something like that, or like a speech to text or a text to speech, or even like things like LiDAR, stuff like that, it would be a little heavier. So keep that in mind, obviously, but we could also tune it back down. We could run 10 servers or something like that. We don't have to run 15, but 15 is pretty cool for the detection. So let's see an example of me like moving this bottle around to give you a better idea of how much smoother it is at 30 frames per second. As if anybody needed to know 30 frames per second would be smoother than 2. So yeah, no surprise, that's a big improvement here. And I'm still tinkering with modifications from here. Like if you have 15 servers, you can do essentially like averaging across them for detection and also for like no detection. So you can still get false positives and false negatives, but having 15 servers, each seeing slightly different frames, means you can kind of come to a consensus, like an ensemble of models. This also means that you can do a whole heck of a lot more tracking. Like you will see degradation and latency from each individual model if you try to track more and more models or more and more objects for that model. But again, we could track 15 different objects, each on its very own server, and have, or we could have like each server track 2 objects and maybe share some of those and all that. Or you could have some doing captioning, some doing tracking, and so on. So anyways, it's a really cool model and a cool example of utilizing the abundance of memory, but also the sort of lacking of memory bandwidth. And I think, again, for like a VLM, especially one where you can track various different types of objects or different types of descriptions and all of that, I just think it's such a cool model and such a cool concept for pairing with robotics, especially when you have a device like this that can totally run on the robot at such low power draw and yet pretty darn good performance. So anyways, yeah, very cool. All right, some closing thoughts on the Jetson Thor dev kit, as well as something related that's on the way that I think people are going to kind of confuse with each other, so I just want to clarify that the Jetson Thor dev kit is out right now. You can buy it. I'll put a link in the description if you're interested. And the thing I think people are going to confuse it with is the DGX Spark, or what was previously known as Project Digits. And they actually have different specs, different boards, different stuff on them. This one has the 20-core CPU. The Jetson Thor dev kit has like a 14-core CPU. There's different stuff. This is different, but two specs, and really the bottleneck on both of these devices is the same, and that is you have 128 gigabytes of memory, but the specification on even the DGX Spark is a 273 gigabytes per second bandwidth. The difference, though, is one of these is aimed at desktop compute, maybe like a Mac compared to like a Mac Mini or something like that, whereas this is meant for robotics. And really, this is the dev kit, right? The thing that's actually going to go into your robot is this little just tiny square right here, right? The rest of this stuff, like this is just heat sink and all that, and then this is your carrier board, and you might want some of these things, but you're probably not going to want all of them on your robot. So if you're like a robot manufacturer, this is what's going into a robot. So it's just this little tiny thing. And the thing is, on a robot, the thing that matters so much here is the 130 watt power draw, like low power draw. Like the lifeblood of your robot is the battery life and the wattage. And so like you live and die literally by power draw. And whereas, on desktop compute, things are a little different, right? On desktop compute, people almost don't care about power draw. As long as it powers off a single outlet, or it can even just be powered at home somehow. Like people don't even care if they have to plug into multiple outlets. So the value proposition is different between these two things, even though the specs are so close. So yeah, and I don't think the DGX Spark is out yet. And NVIDIA, if you're listening, it's way too late. I don't think this exists on this board, but the thing that would make this sell like hotcakes, in my humble opinion, is if there was a little port on the back, and it could even be a proprietary port. We would call it NVLink, and that would let you link these up and scale them out, right? And it would need to have a communication speed similar to the 273 gigabytes per second. Should honestly be equal to or greater than. We're very, very, very close. That would be cool. That would start to make the case for stacking these sorts of things up, and then have some sort of like power distribution or something like that, or let people handle that on their own with like a little a thing that they could plug in and figure out on their own. But that would be really cool. That would start to make sense for this on a desktop compute. But as it stands right now, I think a lot of people are going to kind of poo-poo this because of that memory bandwidth. And in terms of desktop compute, they're going to compare it to slapping a 5090 right into their pre-existing hardware. And it's not going to make sense. It's not going to make dollar sense. And so people are going to hear about the DGX Spark. It's going to have similar specs, all this stuff, and they're going to confuse it, as they already have. It's not even gonna. I've already had people, when I was posting about this on X, people are confusing this with DGX Spark, and they're different. So, but you can learn based on the performance of 273 gigabytes per second. You can get an idea for that. What is that performance going to look like if you buy this desktop DGX Spark? So, anyways, I think this is a slam dunk for robotics. It's a no-brainer. It's a lot of power. It's way more. Like right now on the G1 that I have, I only have 16 gigs of memory to work with on that Orin NX board. And so this is huge. This is great. I am literally going to strap this to Jeff. I haven't decided exactly how. I actually think I'm just going to buy a small backpack or something and put this on his back, because there's like no way I could actually embed this myself into the G1. So anyway, I think that's probably what I'm going to do. But future robots are going to run this board for sure. It's great. It's an awesome board. I think it's a good value proposition. It's nice low power, 130 watts in terms of these like dev kits. It's actually kind of high, but still, it's comfortable enough that you could run it off a battery, and it's not just going to murder your battery like if you were somehow able to run a 5090, for example. So anyways, that's all for now. Next videos will probably be back to Jeff the G1, most likely with something like this, but I do kind of want to do more with the local 480B model, so we'll see, maybe something on that with that Puget 1 terabyte machine. Otherwise, we'll be going back to Jeff the G1 and our regularly scheduled shenanigans there. You guys know the deal. Questions, comments, concerns, feel free to leave them below, and I will see you all in the next video.